Yesterday, we started by verifying number 13.
Okay.
On Monday, remember, we didn't finish 13.
Oh, yeah, we had a big debate about it. Yes.
Yes, we had a long discussion about it. Then we agreed that when we start yesterday, we'll start by checking the answer to it.
Okay, cool.
And then we did that. We worked out number 14.
Okay.
Number 15.
Okay.
And number 16.
Okay.
Now we are starting on number 17.
Okay. Thank you.
Yes. Now, let's look at number 17. Do you all still remember what you need to use to can be able to deal with number 17?
Yes.
There's only one yes. What about the others?
Yes.
Where is this second yes coming from? Let me check. B Bala. Oh, no. Sorry. B Lala. Who's B?
It's me, sir. I'm available. Bongani Lala.
Oh, Bongani. How are you, brother? And Lebang,
Yeah, I'm good,
welcome.
sir.
Okay, thanks. Lebang, welcome.
I'm good, sir. How are you?
I'm good. Now, okay.
So may I ask?
Yes.
So for number 17, what they are essentially asking us to do is we are going to get the inverse of the identity matrix and add it to 2 times the matrix, which is A, and then we're going to confirm that it's equal what is on the right. Is that it?
Theo, let me not say away, but let me, okay, stay on the line. Let me ask Lerato to come in. Lerato?
Oh, okay.
Yes, sir.
Please help out one of the family members.
On number 17, we are using the laws of inverse matrix and transpose matrix, like the one for K A inverse is equal to K inverse times A inverse. Those laws, man.
Okay.
Theo, do you follow Lerato's explanation?
Not quite, but I see where he's going with it.
Lerato, please be specific then. Lerato?
Okay, sir. Theo, on number 17, we are using what's given to us to find the matrix of A.
Okay.
Like, you'll do a lot of things which involve theorems and properties. Like, say, how should I explain this thing? We use properties of transposes and inverses to get a matrix. Like, I don't know.
Okay, Lerato. In simple terms, this is what I'm expecting you to say. Let's say we are looking for A.
Oh, okay.
And then we are given A inverse. What we will do, then we will raise that A inverse to the power -1. Or we'll multiply that A inverse by A.
Yes.
That is what I'm expecting you.
Okay.
I'm expecting you to speak along those dotted lines.
Okay, sir.
So you'll not be giving an exact answer. The reason I'm saying that is because Theo or even those others who are actually not sure of how to approach this, once you give step-by-step details of what is it that we need to do in order to arrive at A, if you give step-by-step explanation, then they will be able to get to that.
Okay, sir.
Yeah.
On the questions that we are doing today, we are using those properties. Properties like inverse of A is equal to inverse of A to the power inverse. No, A is equal to inverse of A to the power inverse. I think I
Okay.
said it correctly. And then we're using the other one which says K to the power A inverse. A inverse is equal to K inverse times A inverse. And
Okay.
then the other ones of transpose. 5 transpose to the power inverse is equal to 5 inverse transpose.
Okay. Okay. You're making sense. Thank you.
Is it?
Yes, sir.
Okay. Thank you, Lerato. Nomtandazo.
Yes, sir.
Yes. What did you get as an answer?
I'm not sure, but I got
Mhm.
minus 8 over 11,
Mhm.
1 over 11,
Mhm.
2 over 11,
Mhm.
and minus 5 over 11.
Lebo. Is Lebo still with us?
Yes, sir. Yes, sir.
Yes. What did you get? Lebo.
I got two by two matrix.
Mhm. Thank you.
I got 2 by 2 matrix.
Yes, I agree with that. Then what are the entries?
For row 1, I got negative 4 over 13 and
Negative
negative
4 over 13. Yes.
13 over 13.
Negative 4 over 13. Yes. That's your first entry. Uh-huh.
Second is negative 1 over 13.
Yes.
And then for the second row, I got negative 2 over 13.
Yes.
And then I got negative 7 over 13.
Lerato, what did you get as the final matrix, my brother?
Negative 1 over 8.
Negative 1 over 8.
1 over 16.
1 over 16.
1 over 8.
1 over 8.
1 over 16.
1 over 16.
Yes.
People, how can, okay, what should I say? How can three people have different answers for one exercise?
Mine is wrong, sir. I saw my mistake. I'm rectifying it.
Who's talking? Is it Nomtandas?
Yes.
Nomtandas, what are you saying?
My answer is wrong.
Who
I did
said
it.
that?
No, I rechecked and I saw I made a mistake somewhere. So I'm working on it again.
So should I ignore what you gave us as an answer?
Yes.
Okay. Lebo, let's
Give
talk.
3 minutes, sir.
Sorry?
Give me 3 minutes. I'm working on it.
Okay, you've got the 3 minutes. In the meantime, I'll be talking to the others. Lebo.
Yes, sir.
Mm-hmm.
Yes, I got my answer by saying
Yes, let's start from the beginning, how you arrived at the answer.
identity bracket identity plus 2a close
Hang on,
bracket.
hang on. Let me write this down. This is an identity plus 2a inverse equals to minus 1, 2, 4, 5. Then I'll be able to follow now. Yes, go ahead.
Yes, and then both of them are raised to the
Lebo,
power. Yes, sir.
Lebo. We
Yes,
are
sir.
starting from the beginning. Ne?
Okay, sir.
Yes,
You
please.
open bracket.
Uh-huh.
Open another bracket.
Mm-hmm.
identity plus 2a, close bracket to the power -1, close bracket to the power -1 again,
Yes.
is equals to a matrix of -1, 2, 4, 5, inverse of that one, which is I'm going to raise to the -1.
Okay.
Yes, and then after that, to the right hand side, is it right? Yeah. To the left hand side, is it right? Yeah, right hand side. I got identity plus 2a.
Hang on. Are you left-handed or right-handed?
I'm right-handed.
Oh, okay.
Okay,
Yes.
on the left, I got identity plus 2a is equals to a matrix of -1, 2, 4, and 5 to the power -1. And then in the next step, I got 2a is equals to matrix of -1, 2, 4, 5 to the power -1 minus identity. And then I say 2a is equals to 1 over open bracket 5 multiplied by -1, close bracket, minus 2 multiplied by 4, close bracket. Are you following, sir?
Okay, hang on. You said 2a is equals to
1 over
2a is equals to, yes,
1
equals to
over, yes,
1 over
open bracket 5 multiplied by -1, close bracket, minus 2a multiplied, not 2a, 2 multiplied by 4, close bracket. So meaning what I'm trying to say, for that step, I was trying to find 1 over determinant of that matrix.
Oh, okay.
Yes. And
I'm
then
following.
adjoint of that matrix is first row is 5 and -2. Second row is -4, -1.
I'm listening.
Minus the matrix of identity is first row is 1, 0. Second row is 0, 1. Yes, and then after that, I got 2a is equals to 1 over 13. I see my mistake. Which is okay, so it's 1 over -13.
I'm listening.
Matrix of 5, row 1, row first row is 5, -2, negative, second row is -4, -1. And then minus the identity of 1, first row is 1, 0, and second row is 0, 1. Yes, sir. So now I see my mistake from there, which on my book I said is 1 over +13, which I should said is 1 over -13. So now I got 2a is equals to open bracket the matrix, that matrix is negative 5/13 first row.
Mm-hmm.
And then second entry is 2/13.
Mm-hmm.
And then in second row is 4/13.
Yes.
And then in is gonna be 1/13 minus the matrix of identity is first row is 1 and 0, second row is 0 and 1.
Yes. I'm still with you.
It's gonna be 2a is equals to 5/13 minus 1. So you know what, I made a mistake. So I don't know if I'm gonna go through with you because I made a mistake.
Oh, okay. Okay. Thank you, Lebo.
Yes.
Please fix your mistake. Nomtandazo, I'll
Yes,
come
sir.
back to you. I'll come back to you. Let me talk to Lerado. Lerado.
Yes, sir. Can you hear me?
Yes, I can hear you.
Okay. First thing I did on the left-hand side, I used the laws of exponent so that I can open the bracket up. Inverse to the power inverse plus 2a to the power inverse equals to that matrix. And then that matrix, I to the power inverse, I moved it from the left side to the right side. And on the left side, I was left with 2a to the power inverse equals to that matrix we were originally given minus inverse of inverse. But we know the inverse of inverse is inverse. Can you understand what I mean? What I'm saying? So, and then
Inverse of an
of
inverse is?
its original matrix, like I to the power inverse, it's I. That's what I mean.
I agree.
So then I got 2a to the power inverse equals to original matrix minus an inverse matrix with two pivots, two ones, diagonal. And
Okay, hang on, Lerado. Lerado?
there's someone talking, it's not.
Lerado, can I interfere? Lerado,
Yes, sir.
I need to make sure that I follow what you are saying.
Okay, sir.
Tell me if what I'm saying is what you in fact said.
Okay.
That means after what you have said, né? That means
Yes.
on the left-hand side, we'll have an identity plus 2a, which is equals to this matrix on the left-hand side to the inverse. Né?
Yes.
Do we agree? That's what you said.
On the left hand side.
Meaning on the left-hand side, we have got an identity plus 2a, which is equals to the matrix on the right-hand side raised to the power -1.
Inverse. Yes, that's what I mean.
Raised to the -1, meaning we now have to find an inverse for this matrix on the right-hand side.
Yes, it's gonna be
Okay.
identity plus 2a.
Yes.
Is equal to 1 over -1, I think, because it's -5 times 5, which is -5, 2 times 4, which is 6, it's -1. And then we use that law.
Hang on. Sorry. I need to follow Lerado.
Okay.
Once you and I can agree on this one important thing, then I don't see us having challenges going forward.
Yes.
Are we saying you and I. Are we saying on the left-hand side, we have got an identity plus 2a equals to the inverse of
The original.
Oh, hang on. Are we saying on the left-hand side, we have got identity plus 2a equals to this matrix on the right-hand side raised to the power -1?
Yes.
Then, in other words, we have to find an inverse for this matrix. Ne?
I've already found it. Yes, that's what. Yes.
All right, all right. Then we agree. I'm okay
Yeah.
then, if that is the case.
The inverse of that matrix, what I got, it's -5, +2.
Yeah. Give me the entries for this inverse that you found. What are the interests? What are entries?
-5, +2.
-5, +2.
+4, +1.
Okay, hang on. Now, please talk to who was that? Please talk to. Okay, I know that amongst us there are people like Levo and Nomtandazo who worked on this exercise. So please talk to everybody about and whether they agree with this inverse or not before we continue.
Okay, everyone, do you agree with the inverse or not?
I don't agree.
I also don't agree with the inverse.
I don't agree. I don't agree with your 1 over your determinant. You said you got 1, +1. Yeah.
Negative, like the inverse of the original matrix. The one we're given.
Yes, for you to get inverse, you have to say 1 over the determinant of that of that matrix and you multiply by the adjoint and you, yes. So now can you tell me what is your determination? Determinant couple determination button.
Level determinant.
Yeah, determinant.
Oh, okay, let me try this way. -1 times 5, it's -5, minus 4 times 2
is 8.
-5 minus 6 minus 11. And then it will be
why
because why -4? Yeah. -1 times 5, it's -1, minus +2 times 4. +2 times 4, it's 8. Minus 5 minus 8, it's 13. Minus 13 minus 13.
Yes.
And the inverse will be -5 over 13. Or yeah, I think that's the inverse.
Yes. So Abana, you are incorrect.
And then +2 over 13.
Correct.
+4 over 13.
Correct.
+1 over 13.
Correct.
Yeah, I agree with you.
And then we have,
yeah. Sorry, Lerato, to interrupt. Do we all agree on the inverse?
Yes, I do.
Do we agree that the inverse is -5 over the entries in the first row are -5 over 13, 2 over 13, in the second row 4 over 13 and 1 over 13?
Yes, sir.
Do we all agree?
But let to continue, and then for those who disagree, they will come back and also state their own matrices.
Abdul, how are you? Good, but okay. Let's just say a few of you do agree with this matrix that Lerato has just shared with us, ne?
Well,
yes, sir, I do.
Methods, I did my own operations, so it doesn't line up or add up. So I would say Lerato can explain what he has done. And then if anyone has a different method or whatever they used, they will also come into the platform And then
Yes.
at the end, you will help us to say that which one is the correct amongst them all.
Okay, thank you. So now, Lebo, do you agree with Lerato up to so far?
Yes, sir.
Pio, are you in agreement?
Oh, yes, I am. Yes, I am.
Who else? Nomtanda as well?
I am.
Have you got a different view?
No, it's okay.
Hmm?
I'm with Lirato.
Okay, Lerato, please continue. We are
Now
listening.
we have inverse plus 2a, it's equals to the inverse. Like,
Huh?
say, we had I plus 2a is equal to inverse. That's where
We
we
found
are
the
now.
inverse. We
We
found
found
the
the
inverse.
Yes.
So we move the I.
Now, let's use this terminology correctly. Now, you and I agree that on the left-hand side, we are left with an identity plus 2a equals to the matrix that you just found. Ne?
Yes.
Oh, okay. Yeah,
And
take
then
it from there.
Now on the left-hand side, we have 2a, it's equals to the inverse that we found minus the, and then the inverse that we found minus the identity. This is what I got.
I agree with you. No, not to say I agree with you. I hear you. Yes.
This
I'm
is what I
following
got.
you. I'm following you.
I got negative 18 over 13.
Okay, hang on. Now on the left-hand side is 2a, ne?
Yes.
Now the inverse that you found after subtracting the identity, which is 1001, then what
Yes.
what did you get?
Negative 18 over 13.
Negative 18 over 13, yes.
Positive 2 over 13.
Positive 2 over 13, yes.
Positive 4 over 13.
Positive 4 over 13.
Negative 12 over 13.
Negative 12 over 13. Now let's stop here. Please talk to them
Agree.
about this matrix that you are having on the
Agreed.
right-hand side.
Agree. They agree.
Hmm?
They agree.
Are you forcing them to agree or do they agree? Because I didn't hear anyone.
Okay, just
Yes,
Lerato,
agree.
I'm sorry about this, but do you mind just reiterating the matrix one more time, please?
Negative 18 over 13, 2 over 13, 4 over 13, negative 12 over 13.
Yes, man. Yes.
And then we have that 2, that side.
Yes.
That 2, I'm not sure you multiply by 2 or you multiply by half.
Multiply by half.
Multiply by half.
We're not talking too late.
Why are you fighting today? Hey, is it a fight today? What's going on? Lerato, are you fighting with me? I tell you are saying you are not sure. So I'm making you to be sure.
Yesterday it was 2, today it's half. How come? I will discuss that. I used 2, which means my final matrix is wrong because I multiplied by 2, not by half. That's why when they said half.
Lerato,
Yes, sir.
you said you multiplied by 2.
Yes, I multiplied by 2.
Okay. May I please request Levo to help us, because Levo, please come in.
Yeah, so you multiply by half, because for you to remove that 2, that side, like when you solve for x, for you to remove that 2, that side, you have to divide by 2. So now we can't divide. We have to multiply by 1 over 2. Yeah, Mon.
Yeah, please talk to Levo. Please talk to Levo. Please talk to Lerato.
Lerato. Kamoya
I'm
offers.
busy here.
Kamoya offers, yes.
Kamoya
I'm
offers.
busy here.
You multiply by 1/2 because you have 2 that side, which is you have 2a. So for you to remove that 2, you're supposed to multiply by 1/2. So half multiplied by 2 is 1. And what you are doing on the left-hand side, you are supposed to do on the right-hand side. You
Yes,
understand?
Lebu.
So.
I understand.
And then your
Then,
matrix is gonna be, yeah.
then Lebo,
Yes, sir.
after we are following you now. Lerato, you are not off the hook. You are still with us. Lebo,
Yes, sir.
now we agree that we need to multiply by half. Now, what will the final matrix then be when we multiply by half?
And then the final matrix is gonna be, first row is gonna be -9/13, and then 1/13, and then in second row is gonna be 2/13, and then -6/13. Do you
Please
agree with me?
Agree.
Please
Yes,
repeat,
we
Lebo.
agree.
I should repeat my matrix, sir.
Please.
Okay, first row, which is
Lebo,
first. Yes, sir.
Kamoya offers, please.
Is 2 by 2 matrix. So it's gonna be, first row is gonna be -9/13, and then 1/13. Second row is gonna be 2/13, and then -6/13.
Thank you, my sister. Please ask them whether they agree with you or not.
People, do you agree with me, guys?
We agree
Yes.
with my king and your answer.
I
You
agree.
agree with me with what?
My working and your answer, we agree.
Yes, we agree. The most important thing is that we agree. Thank you, Lerato. Thank you, Lebo. Thank you, everybody. Anybody who doesn't follow how this exercise was actually handled, please talk to us before we continue. Someone is talking. We can't hear you.
I'm talking, so can you hear me?
Abdul,
Can you hear me, sir? Oh,
are you in a mine today?
I'm all right, sir. Can you hear me? I'm not sure. I'm also load shed here, so I'm not sure if it's network or what.
Yeah, now I can hear you.
All right, all right. So
It
that's
looks
what
like
I'm
you. It looks like you were speaking from under the mine.
saying. I don't know what's going on. I don't load shedding. So,
Yeah, your voice is fluctuating.
yeah, skis is load shedding. So now what I was saying is that I used a different approach and I also got a different matrix. So if people are agreeing, can maybe you help me out with this one, this method that I used to say, what did I do wrong? So
Okay.
on the left hand side, we have I plus 2a raised to the power of -1. So what I did in terms of that, I distributed my -1. So the identity matrix had its negative power plus 2a to the -1. And then from there, I multiplied the left with an identity matrix from left to right. And after doing that operation, I'm now left with 2a to the power of -1. And then when I go on to my right-hand side, I multiplied by my identity matrix and it returned that same matrix of -1 and 2 in the first row, and then 4 and 5 in the second row. So now my equation reads 2a to the inverse equals to -1, 2, 4, and 5. And then from there again, I distributed the -1 to the 2 and the a itself. So now I have 2 to the negative 1 multiplied by a to the inverse as well equals to 1, negative 1, 2, 4, and 5. Then I multiply both sides with 2 in order for me to get rid of that 2 to the negative inverse. So it's the same as what Lebu was saying, 2 times a half, they cancel each other out. So meaning I'm going to be left with the inverse of A on the left-hand side. And then on the right-hand side, when I multiply my matrix, my new matrix now after being multiplied by 2 will read negative 2 and 4 on the first row. And then on the second row, we have 8 and 10. So the equation reads a to the negative 1 equals to 2 and negative 2 and 4, and then 8 and 10. Then from there, I found the inverse of that inverse. So finding the inverse of a to the negative 1 will bring out that a is the final matrix. Then what I do on the left, I do on the right. We all know the inverse of a matrix is 1 over the determinant times the adjoint. So in this case, my determinant, I found it to be negative 52. So I had negative 1 over 52 multiplied by the adjoint, and my adjoint matrix is 10 and negative 4 on the first row. And then on the second row, I got negative 8 and negative 2. Then after performing or multiplying by negative 1 over 52, my first entry for my final matrix was negative 5 over 26. My second entry was 1 over 13. Moving on to the second row, I got negative 2 over 13 and 1 over 26. So what is it that could have gone wrong along the way in terms of the laws that we follow in terms of solving our matrix with what I've done?
Let me allow others to come in before I come in. Hello, everybody. Let's help out here. If there is a need to help out. If there is no need to help out, then.
So I think the operations somewhere, something happened.
We.
I'm not sure where, like.
Starting from the initial one, let's start from the top. That I plus 2a raised to the negative 1. I distributed that negative 1. So meaning we now had an equation that reads I to the negative 1 plus 2a in brackets raised to the negative 1. So is there anything wrong about that operation to start with?
No, after that, what did you do with the I?
And then after that, what I did now is that I multiplied I with an identity matrix, the I to the negative 1. I applied it with the identity matrix. So it's that inverse thing, they should cancel out.
Yes.
Yes.
I to the power of I.
Yes. And then now after every operation on the left hand side, I'll be remaining with 2a in brackets raised to the negative 1. That's on the left. And then on the right, again, it doesn't change that matrix. It comes back as negative 1 and 2 on the first row, and then 4 and 5 on the second row.
Yeah, my sister. Okay. Lagato, you can say something. I'll go after you.
Like, if you did that, the final matrix must be 2a to the power minus 1 equals negative 2, positive 2, positive 4, and positive 5. That's the matrix you should get. And then find it.
Remember, in brackets, we have 2a raised to the negative 1. And yes, in that case, when I distribute the negative 1, I'm going to have 2 to the power of negative 1 times a to the power of negative 1. And multiplying by 2 will cancel out this 2 to the negative 1. And then I remain with a to the negative 1. Do you agree?
To multiply by half. It's not.
Yeah, man. You see where you came from? You are saying left hand side, which is you said you raise I to the -1 and just
Yes, I distributed
plus
that negative.
2a to the power -1
Yes.
is equals to that matrix.
Multiplied by the identity as well, because what you do on the left, you do on the right.
I don't follow you. You multiplied by identity again.
So listen, from that distribution, from distributing the -1, I had an equation of I raised to the -1 plus bracket 2a raised to the -1. After I distribute the -1, do you agree?
Yes, is equals to?
Is equals to -1, 2, 4, and 5. Nothing is happening on the left-hand side because of I didn't distribute. I just distributed on the right-hand side.
All right.
Because what is on the left doesn't necessarily, I didn't change anything. I just distributed.
Yes.
There was no changes.
Sure. And then after?
So, after that now, and then I multiplied by an identity matrix. So now I'm multiplying the right with an identity and I'm multiplying the left with an identity.
That's where you got, Matuso.
Yeah.
That's where you've gone wrong. You see, identity plus 2a, we have a sign in between, not multiplication. If we had a multiplication in between, that's where you were gonna multiply both with a 1 over identity, actual, not identity.
Why am I saying this? Is this
Oh, maybe is it because identity multiplied by identity is 1?
Yes.
Okay, go through.
So that's the concept I was looking at. For me, that's how I eliminated my I. And that's where we landed now with 2a raised to the -1/2 equals to this matrix, -1, 2, 4, and 5. So it's like I basically multiplied by 1. It didn't change anything. However, through doing that operation, I managed to get rid of I. So now I has been eliminated, and what I did on the left is what I did on the right. Then moving from this 2a, again, I eliminated this 2 to the -1 by multiplying by 2, because 2 to the -1 is a half. A half times 2 is 1. So that's how it gets eliminated. So I multiplied the right with 2 and the left with 2. So now the new matrix would now read -2 on the first entry, first row, and 4. And then second row is 8 and 10. And now this is equivalent to the inverse of A. We still don't know what A is, but this matrix now says it's equivalent to the inverse of A. Then I found the inverse of an inverse. After having performed all that, that's where I found that final matrix that I spoke about of A being -5 over 26 for the first entry. And then second entry, first row is 1 over 13. And then second row is -2 over 13. And then my last entry would be 1 over 26. So based on the operations I did, if nothing is wrong, according to you guys, or say, or if everyone agrees with me, then it therefore says between my method or the method that the other colleagues used, there's one of them that is wrong, because we can't both use different methods and still get to different outcomes. I was going to understand if we go to the same outcome. Yes, some entries, especially the 1 over 13, it checks out. And then some of you guys got +2 over 13, and I got -2 over 13. So
yes,
then,
and listen, Matuso, listen, sure. You still have A inverse on your right hand side, which was the first, it was 2 to the power -1 and A to the power -1, and just is equals to that matrix, and just run the one we got, and then you multiply by 2.
Correct.
And just from the left hand side and the right hand side, right? And then for the left capo right ya mara on the right hand side you left with A inverse is equals to -2 negative 2, 4, and then in positive 8, and then in 10, right?
Yes, you're correct.
Yes, and then what have you done with that A inverse? Because we want A, not A inverse.
So remember, an inverse of an inverse will give you that thing that is inside. So if you have A inverse, finding the inverse of A will give you A. So I found the inverse of the inverse.
You find the inverse of the inverse. How? Can you just read that for me?
It's going to brackets A to the minus 1 raised to the minus 1.
All right. Mm-hmm.
And then that will now reduce to A, fella. So finding an inverse of the inverse, it will bring out A. So it takes care of the left-hand side. Going on to the right-hand side, it will be 1 over the determinant times the adjoint.
Mm.
And then going back to that matrix, A raised to the negative 1. It is negative 2 and 4.
Uh-huh.
And then 8 and 10, right?
And 10. So but the inverse here, this matrix now, I just
looking for the determinant. Yes. So with this matrix, I'm looking for the determinant. So negative 2 times 10 minus 8 times 4 will give us a determinant of minus 52 or negative 52. That's the determinant of that matrix.
Oh, am I yes. 1 over 52. Yes.
Yes. So it's going to be negative 1 over 52. Do you agree with that part?
Yes.
Fine. And then let's go to the adjoint. Let's swap on the main diagonal. The 10 will go on top, and then the negative 2 will go at the bottom. Do we agree?
Yes.
Okay, fine. And then 4 and 8, they get negatives. So now the adjoint matrix will read 10 and negative 4, negative 8, and negative 2. Do you agree with me?
All right.
And then if you do your multiplication, this matrix that I spoke about, where we agree on an entry, but the other entries, you have a different sign than mine, and then the other two, they just don't correspond.
Yeah, I see. Well, they don't correspond. Let me see. So if you want to correct us, you can come through. Your first entry is the one that is not corresponding.
But I also used a different method and I got the same answer with Lewu and Lerato. So I don't know.
Your first entry and your last entry, they are not corresponding with mine. So can you come through, please? What happened?
I want to come in, but I got lost in the process. I don't want to lie.
Yes,
I don't want to lie.
So identity, inverse of identity multiplied by inverse of, the inverse of identity multiplied by the inverse.
That's why I'm saying, Abdul.
Yes.
That's why I say I haven't got a problem.
Yeah. You know what I think, Matuso? You know what I'm thinking? I'm thinking if you multiply that negative 1, 2, 4, that matrix by that inverse, is it gonna give you that matrix?
According to my working out, I can't multiply by any inverse because I didn't invert anything on the right-hand side. I was going to understand if I inverted something on the left, which was going to require me to also apply the same on the right.
Yeah,
But in this case,
so,
there's no operation that required me to change anything or whatever. So far, I
yeah,
followed the rules.
not inverse, in identity. If you multiply that matrix with that identity, is it gonna give you that matrix on the left hand side?
Identity matrix times any matrix gives you that same matrix. It's like multiplying by 1. If you
Okay.
can look at it.
Oh,
So based on that logic, that's where I can say I differ with you guys, also based on the method, which is why I would like to get clarity now, looking at the fact that some of our entries don't correspond. Talk to us. Say, what do you think?
yeah. So can you please come in? Because I don't see any mistake.
The mistakes are in row operations. That's why some answers are like ours and the others are not. Somewhere there.
Somewhere where?
Row operations.
So hence I was saying, like I was stating each and every step so that you guys can follow. And if there was a
Give us the
mistake, I was hoping that you guys can come in
Hard for
and
us
say
to follow
this.
because we all use different
give us
methods.
Which
I
matrix do you
also
want?
use
the one you must try.
different methods from you guys, and I got Abdul.
The
Abdul.
one you put before.
Talk to me, I'm listening.
I also used a different
Hello?
method from the one that Lirato and you did. And I also got the same answer with Lirato and Lewhang. So I think maybe you must check again how you did it. It's hard for us to intervene because you used a different method from all of us.
The question here is, I'm not saying I'm right or you guys are wrong, but there are chances that there's either me or you guys that applied the rules wrong. So now that's why I'm like, can say come in to just decipher for us to say who didn't follow the rules correctly.
Yes.
Okay, now, the route that you took, let me not follow the route. Let me not follow you on this path that you followed, okay? Are you with me? Let me not follow you because I get lost along the way on the road that you took. Let me take you through the road that I followed. This is the road, this is the path that I followed. I said on the left-hand side, it is I, which is an identity, plus 2a, everything raised to the inverse, okay? Equals to the matrix on the right-hand side. Then the next thing that I did, on the left-hand side, I put everything inside the big bracket and raised everything to the power -1. Are you still with me?
Yes, sir.
And then on the right-hand side, I raised that matrix to the -1, which simply means that on the right-hand side, I then need to find an inverse for that matrix. Still with me, Abdul? I can hear you from very, very far.
I'm with you, I'm following.
Oh, okay. Okay, then from there, I said, on the left-hand side, I'm now left with an identity plus 2a, which is equals to that matrix raised to the power -1. Then I took an inverse for this matrix minus 1, 2, 4, and 5. Okay.
The inverse of that.
After getting an inverse, then I subtracted an identity matrix from it. Are you still with me?
Yes, sir.
Then on the left-hand side, I'm left with 2a.
Yes.
Then I had to divide by that 2, meaning I multiplied by half.
Correct.
Then I ended up with a on the left-hand side, which then gave us the matrix that was found by Lerato. Abdul?
Yes, sir.
That's how I approached it.
So I think it must have been then some of the operations like Lerato might have suggested that I've done along the way that must have maybe gone missing or gone wrong. But following your procedure and what you did, it makes a lot of logic and I understand it.
Because I want to help you, but in the process of you solving, I get lost. And now I become just worthless to you because I'm unable to get where you made a mistake.
So what we could say, according to this, my mistake trying to look at what you did is that subtraction of the identity matrix. So now there was no part where I subtracted that part. If I'm to follow your logic and try and align it with mine, I was also supposed to subtract that. So I didn't subtract.
In the process, are you saying to me, in the whole process, there is no way where you subtracted the identity matrix?
I can say I tried neutralizing by multiplying by the inverse of that matrix.
Phew.
And in my head, I thought that it's going to make it fall away, but that identity matrix is still there, which I was supposed to subtract from the inverse of the other one on the left-hand side. I mean, on the right-hand side. So the problem is solved. I see where the problem is in terms of my operations.
Are you sure you see where the problem is?
Yes, 100%.
Yes, sir. Can I get in between?
Yes, come in, Level.
So, sir, I don't think Matusa is incorrect. I don't know if you see that. Matusa is saying he multiplied with identity to remove that identity, that side.
Meaning on the left-hand side, if I hear you clearly, Level, I stand to be corrected. Must also multiply this identity because on the left-hand side, we have got an identity inverse. Ne?
Yes.
Meaning he multiplied this identity inverse with an identity.
Yes.
Okay. Then when we do that, what we get?
This operation should still give us an identity matrix.
Oh,
So,
yeah. Yeah, so now I see. So now this guy multiply an inverse of identity and identity. So
Yes.
he was supposed to get 1, not nothing, 1. Because he got nothing. So he left with 2a. He was supposed to left with 1 plus 2a.
Which is the identity matrix, how I share, but not exactly 1, but the identity matrix. And then according to these steps, that identity matrix was supposed to be subtracted from the other side. So now I didn't subtract it in no way. So that's how I can say I went, of course.
Yeah.
Yes.
Yeah. Now I see.
But before we can say yeah.
Mbongizeni's hand is up, Glenn, and he's being.
Okay, thank you. I will talk to Mbongiseni now. Level.
Yes, sir.
And Abdul.
Yes, sir.
Before this discussion. Now, let's reach an agreement here. And because on the left-hand side, we have got an identity ray. Okay, let me say what is the inverse of an identity. Okay?
Yes.
And then Abdul multiplied the inverse of an identity with an identity.
Yes.
Do we agree, Abdul?
Yes, sir.
Abdul.
Yes, sir. It's correct. Can you hear me?
And then after that, what did you get?
So I was supposed to get I. Now I neutralized it. I thought they were canceling each other out. Because the inverse of an identity times an identity is still an identity.
If you are having I multiplied by 2A, if you were multiplied by that I, the integrate goes. So now we have a sign in between. That's why we left with that identity, not nothing. Yeah, now I see him.
Yes.
Are we in agreement now?
Yes,
Yes.
sir.
Abdul, is it clear now?
It's clear, sir.
Thank you. The set someone who
Mbongiseni.
someone Mbongiseni.
Okay, no, good afternoon and thank you, Honorable Nyanga, for recognizing me. Thank you so much. Glenn, mine is just straightforward. When you were giving us your procedure or the way you did this, I just want to know, is there a rule or is it a theorem or something? How did you get rid of the inverse on the left-hand side and moved it to the right-hand side? If you can just clarify that to me, I should be good to go. I will be unconfused.
Okay, this is what we are saying. Mbongiseni,
I'm listening.
let's go to one of the villages that I'm staying in.
Yes.
Let's go and visit that village.
All right. I'm going with you.
Okay. Okay. Thank you, my sister. Then, please give us an answer to number 18.
On the first row, I wrote 5 and 1.
5
and 1.
and 1. Mm-hmm.
And then on the second row, I wrote -3 and 2.
Okay, Dalva. You said to me in the first row, I should write 5 and 1.
Yes.
Which is what I did. And then you said to me in the second row, I should write -3 and 2.
Yes.
Which I did. And I thank you for that. Would you please take us through the steps that you followed to get to this matrix? In other words, please explain to us how you arrived at this matrix.
Yeah. I don't know how to explain that. But what I did was, isn't it that we are given the inverse of A, which is that matrix 2, -1, and then 3 and 5. So
what I did was I said I have to interchange the 5 and 2. So the 5 will come on the first row, and then the 2 will be on the last, on the second row, the last number. And then on the first row, I have to write because now we are given -1, which is on the inverse, it's negative b. So I have to remove that negative sign to make it 1. And then on the other side, the c there, it's -3. I have to remove that negative, then it's gonna give it, it's gonna be since it's 3 there, then it's gonna be -3. I don't know if that makes sense.
My sister.
Yes, sir.
Do you see all the people who are in this workshop with you and I?
Yes.
Thank you that you are able to see all of them. Please talk to them. You can even call them individually by their names and ask them whether they agree with this final matrix that you gave me, because it's a nice matrix. This matrix, I like it. I like your matrix. But even if I do like it, I don't know whether those others, the others in the workshop, got these beautiful or nice numbers that you got. Please talk to them.
Lerato, can you please intervene, please?
I disagree. Like if one more step, yeah, almost there. One more step, yeah, almost there.
Can you please help me?
It's in the adjoint matrix, but there's something missing. I agree with you, Ned Alva, with the main fact that whatever matrix you got is the adjoint, but there's something missing with the matrix.
1 over determinant.
Oh, okay. Okay, now I see.
Almost
Now I
there.
see. Okay.
It's like
How many seconds do you need, Dalva, to get what they are saying is missing?
Just a minute.
You have got that minute, and then when you are done, tell us and then give us the final matrix. Then we'll write it down. We'll go back to them. We'll go
And
back.
Mbongiseni's hand is up after that.
Oh, okay. Mbongiseni, while Dalva is still working, Mbongiseni?
I'm not sure if you're going to wait for Dalva to finish, but I wanted to check if you did the good job when you were explaining this to me.
Oh, okay. Yeah, we can talk. Dalva is working, but you and I can talk.
Okay. So basically on number 18, we're looking, okay, from number 15 to 18, we're actually solving for A in simple terms. So in number 18, we are being told that inverse of A is equal to that given matrix. Then what I did is, I started smiling at label by putting everything to the power inverse to make my left-hand side to be equal to A. Then my right-hand side was still to the power -1, meaning I had to find the inverse for my right-hand side. What did I do there? I first calculated the determinant for the right-hand side, which gave me 13, 10 plus 3, which is 13. And then I calculated the adjoint or whatever you call it.
Whoa. We need the correct word. You see now, how will we become the qualified or the professional mechanics if we are not using the correct tools?
Okay.
What did you calculate?
They add something. Lerato, Lebo, I'm smiling at you, Mos.
Yes, I'm also smiling at you.
You should be smiling me with the pronunciation.
Adjoined. It's
Oh,
adjoined.
adjoined.
Yes.
Thank you, Lebo. So I calculated the adjoined, which I got the same matrix that Dalva found. And then I divided that by 1/3, which is one of the determinant. Then my row number 1 on the final answer was 5/13. And
5/13?
1/3.
1/3?
1/13.
Oh, 1/13. Okay.
Yes. Then second row, it's -3/13.
-3/13.
And then 2/13.
2/13.
Yes.
Agreed.
I agree.
Is this your final matrix?
I agree.
Then you did a good job.
Ebon. Theo, Abdul, Engon, Mbongiseni.
He said before you go,
Let me be the first one to. Let me be the first one to say Eshe. Okay. I'm jealous now. I'm becoming jealous now. Let me be the first one to say Eshe. But then let's wait there. Mbongiseni, ne? Mbongiseni.
Yes, sir.
I'm congratulating you. Abdul, Pio, and the others will follow. But now, remember, we have got someone on the line here.
Yeah,
Dalva.
Dalva is trying to say something, but I can't hear her voice.
Dalva, please talk to us. Mbongiseni will come back to you. Dalva.
I was just following on what he said and I got the same answer as he did.
What did you get, my sister?
I got 1 over the determinant is 1/13. And then multiply by that matrix, then it's gonna be 5/13. And then 1/13, -3/13, and 2/13.
Okay. Mbongiseni. Thank you, my brother. Thank you for the job well done.
Thank you.
Dalva.
Yes, sir.
My sister.
Yes.
Thank you for the job well done. That's how these things are handled. Now, Abdul, Theo, and the others, please come in.
I came, say, I said, hey, shit, I agree with Mbongiseni in Kabiam.
Okay.
Where are you staying? I need to sort you out. Where are you staying? It's almost 7 o'clock now. You know what I'm good at.
Mbongiseni.
Okay.
Yepo.
Mbongiseni, someone is talking to you?
Yes.
Can you please reread your answer again?
My answer, the final answer, ne?
Yes.
On row number 1, I've got 5/13, 1/13. Ne?
Yes.
Row number 2, it's -3/13 and 2/13.
Oh, okay.
Okay. Thank you.
Thank you, Mbongiseni.
Who was talking? Is it Nomtanas?
Yes, Namtandas.
Okay, thank you, my sister. Can I come in? All right. Now, let's look at number 19. In number 19, they are saying, in exercises 19 to 20, compute the following using the given matrix A. Okay. Do you all see matrix A in 19? No.
Yes, sir.
Please use matrix A in 19 to find number A, 19A, 19B. Okay, let me be slow here. Okay, first of all, find A, which is A cubed, to avoid confusing others. When you are finished, then do let me know. We verify before we go to number B. Vincent, what did you get, my brother?
First row 27.
Whoa. I'm saying Mike. Mike, then followed by Vincent. Mike?
For the final matrix.
Yes.
For the final matrix, it's a 2 by 2 matrix.
Thank you, brother.
The first entry, the first row, first entry, I got 41. The second entry, first row, it's 15. Second row, first entry, it's 30. Then second row, last entry, it's 11.
Okay, Mike, you said it's a 2 by 2 matrix. First entry in the first row is 41. Second entry in the first row is 15. In the second row, first entry is 30. Last entry is 11. That's what you said, ne?
Yes, sir.
Please talk to them. Whoa. Before you talk to them, let's bring in Vincent. Vincent, what did you get, brother?
I got the different one. Like, I don't know whether.
Yes.
Yeah, I got 27.
Hang on, 27. 27. 1.
8.
I'm getting confused. What did you get, brother? Let's start from the beginning.
27.
Yes.
1. 8. 1.
1. Now, Mike, is your turn to.
Yes, sir.
Now is your turn to talk to the other family members. After you, it will be Vincent who will then talk to the family members. The stage is yours, brother.
Hello, guys. Did anyone get the same matrix as I did?
Yeah.
Oh, yes.
Mike.
Yes.
Oh, you got the first entry as 41. It's you.
Yes.
Oh, yeah, I agree with you, Mike.
Wait, sir.
I also agree with you, Lebu.
Sir. Mike, man, ish. The question.
Hello.
Ish. The question I'm doing is number 19 for a to the power 2.
To the power
No,
3.
it's a to the power of 3.
To the power 3.
The thing is, I'm on audio mode so that network can work. So I can't see properly. I just write fast. Okay, I agree. A to the power 3. Okay.
A to the power 3 is what you are looking for.
Let me just finish up here. A to the power 3.
Now I agree with you, Mike.
Level, do you agree with Mike?
Is this?
Yes.
Who else agrees with Mike?
What about the others?
Yes, sir. Yes, sir. I agree with someone who said for the first row is 41, 15. For the second row is 30 and 11.
That's Mike. Who's talking?
Yes, it's
Is
Mike.
it Vuyo?
It's Vuyo.
Okay,
Yes, sir,
Vuyo.
it's Vuyo.
Thank you, Vuyo. So, now, up to so far, is Vuyo, and who else? Who else agrees with Mike? Is Vuyo and who else?
I also agree, sir.
Who? Nomtandazo.
Yes, Santanda.
Nomtandazo. Vuyo. Abdul, I hear you. What are you saying? I can't.
I agree with the matrix of 27, 1, 8, and 1.
Okay, well, we'll still come to that. Let's, don't disappear, Abdul. Wait where you are. We are still focusing on this one of Mike. Nomtandazo agrees with Mike. Vuyo agrees with Mike. Who else agrees with Mike?
Lerato.
Lerad agrees with Mike.
I
With this
also agree
matrix,
with him.
we now add Theo. Who else? Okay. Is that all? Are you all who agree with Mike? Vincent?
Yes,
Okay,
sir.
Mike. Okay, hang on, Vincent. Mike, the matrix that you have asked me to write and which I did has got the following entries in the first row, 41 and 15. In the second row is 30 and 11.
No,
Now,
sir.
Yes.
It's 27.
No, hang on. Whoa. Hang on. I'm saying the matrix that Mike asked me to write down has got the entries in the first row, 41 and 15. In the second row, 30 and 11. And then to this matrix,
Yes.
Pio, Nomtandazo, Vuyo, and Lerato agreed to this matrix. Now, there is Vincent, who has got this matrix, which has got these entries. In the first row is 27 and 1. In the second row, 8 and 1. Now, Vincent, please talk to them. It's your turn.
Okay. Yeah, that's the matrix I got. And then, is there anyone who have any other suggestion that or who don't agree?
Yeah, now what I can say is that can you just explain step by step what you have done so that we can help you?
All right. What I did like A cube is the
Vincent.
same. Yeah. What I did is like A cube is the same as A squared times A or A.
Oh, Vincent. You said your working is that cubed. You cubed each and every number on in other
in the matrix.
In the matrix.
Yeah.
Yeah, it's incorrect, my guy. I was there, Linda. I was doing the same thing you did, but now because I attended this workshops, I rectified my mistakes. They did help me, so I'm gonna help you too today, ne? So what you have to do, ne? It's like they are saying open bracket, 3 brackets.
Okay.
Just like squared, just like when you are having a bracket and then you have to it has a squared, it raised in a squared, so you have to open 2 brackets, and yes, you know that. So even here it's the same thing. That matrix you have to I guys to Sankas Kwamo. I don't know if Vincent was it Lesotho.
3 matrices.
expand the brackets 3 times and then
Yeah,
you
go ahead,
the
Level. Go ahead. I will understand along the way. Don't worry.
Multiply 3 matrix. Multiply 2, multiply the other one.
I'm still listening.
Yeah, so you have to have 3 matrices, multiplying those 3 matrices, the same matrix.
Yes.
Yeah.
That's what I said. I said A.
Mm-hmm.
Uh,
And then you start multiplying 2AA, which is 3121, multiply by 3121. So Mara, you have to follow the procedure of how to multiply matrices. Anya.
Oh, by the way, what you want to say? Let's say 3 1 and then 3 1 and then 2 1. All right, and then 3 multiplied by 3 and then plus and then 2.
Yes. And this is gonna be 3 multiplied by 3. It's gonna give you 9. Plus 1 multiplied by 2 is gonna give you 2.
Which is 11 and then multiplied by 3 and then plus 1.
Yeah.
3 multiplied by 3 is 9 and then plus 1 multiplied by 2 which is 11 and then 11, then carry on from there. That's my first entry, like 11, and then which is waiting to be multiplied by the row of like 2 and 3 again.
So your second entry is gonna be 3 multiplied by 1.
No, let's start from like this, and then you said it's 3 multiplied by 3, and then plus 2 multiplied by 1, and then which is 11. Then
yes, it's your first entry. And your second entry is gonna be 3 multiplied by 1.
3 1 and then 1 1.
Yes.
And then which is
4.
4, yeah.
Okay. And
Okay.
then another row, second row.
Yeah, I do understand. So I see my mistake.
Oh, you see your mistake now. All right.
Level, is he sure that he sees his mistake?
Are you sure, my guy?
I'm sure, Dr. Glenn, like I just like cube root and then everything, like then I see now like I have to use my multiplication of matrices, and then which is like a row multiplied by a column, and then add and then yeah.
Level.
Yes, sir.
Does my guy follow?
I think he's following. I'm not sure. I'm not satisfied.
Oh,
I'm also not satisfied.
Oh, carry on.
I'm not convinced.
Yeah, and then after that you go to a second row, and then second row you are going to say 2 multiplied by 3 is gonna give you 6, and then 1 multiplied by 2 is gonna give you 2, which is 6 plus 2 is gonna give you 8. And then another entry is gonna be 2 multiplied by 1 is 2, plus 1 multiplied by 1 is 1, is 3. 2 plus 1 is 3. So now you are having two matrices, which is the first one is gonna be 11, 4, 8, 3, and then the other one which you multiply it by is gonna be 3, 1, 2, 1. You are following, Vincent?
Yeah.
Yes, and then you are doing you're gonna do the process again. It's gonna be 11 multiplied by 3 is 33. And then in 4 multiplied by 2 is 8.
And then which will be 41.
Yes. And then it's 11 multiplied by 1 is 11. 4 multiplied by 1 is 4, which is 11 plus 4 is 15.
Okay.
And then 8 multiplied by 3 is 8. Oh, it's 24. Plus 3 multiplied by 2 is 6. Yeah. And then 24 plus 6 is 8. And then in 8 multiplied by 1 is 8. 3 multiplied by 1 is 3. 8 plus 3 is 11. You see now?
Okay. Yeah. Ngiyabonga.
Masuso, you are saying?
The final matrix of A cubed. What
Yes.
Okay. No, I wasn't following the multiplication of matrix. I just raise anything to that number. If it was like 8 to the power 5, I'll just say 8 to the power 5. So the same, which means like I must say 8 upon 5.
And no, there is there's I don't know, it's some of what. Sir, can you just show that again? That sum of something.
I mean,
if you are having,
you are not helping me if you are saying some of something, because I don't know what that something is.
All right, that rule whereby if we are given a matrix to the power 100, we can't open a matrix, multiply 100 matrices, because it's gonna take a long time. So there is this formula thing. I can't remember it.
The Riemann sum.
Yeah, arithmetic sum.
Riemann sum.
What?
Riemann sum.
Sir, can you please show us that tool?
Sigma notation.
Sigma notation, yeah. How?
Lebo.
Yes, sir.
Kamoya all Lerato, please help out.
It's Sigma notation.
Yeah.
Thank you.
Sigma notation. Yeah, you can show it again, sir. I also forgot that one.
My question is like, if it was 8 to the power of 5, and then did I use the same thing now?
Yes, if you have time, but we have a sigma notation here. So can you just show it to us?
Level.
What is the? Yeah, yes, there is someone who's talking behind. Who's that?
It's not that. Which question are we doing?
19.
19.
Oh, okay.
Then you were still talking, Lebo. What were you saying?
I'm saying, sir, can you please show us that sigma notation again?
Sigma notation.
Yes.
For matrices.
Yes.
Okay. Now, what are you saying? I'm on.
This guy is saying
head for matrices.
So,
what is he saying? What is your guy saying?
This guy saying,
what is
my
guy? You are saying Vincent is my guy. What is my guy saying?
No, I'm not saying my guy saying. No, I'm saying this guy.
Okay.
This guy is saying, what if now we are giving 8 raised to the power 5? Are we still going to do the same process? So I'm answering him saying, yes, if you have time, you can do the same process. But now we have this formula of sigma notation, and last time you were showing it to us. So I'm requesting if you can do that again.
Okay, now let me simplify your life. Ne?
Yes, sir.
Simplify your life. When it comes to matrices, matrices are different from numbers. Okay.
Okay.
If it is 10 to the power 5, we know that it will just be 10 times 10, 5 times. Okay.
Mm.
But then if this A is a matrix, that means we have got A times A times A times A times A. 5 of them. Okay. That means there is no shortcut in here in matrices. That's why I think it's on the second level. What is that? What is that course called? There is another course. I'll remember. Is it numerical? I think we did that at honors level. Numerical analysis, where, let's say, if you've got a matrix, let's say A to the power 5 or matrix, any matrix to any power, there is a software that is used to solve matrices. Let's say, for example, what should I say? Let me say even bigger matrices to save time. I don't know whether you follow me on that one.
We follow this.
There is a software. As you move along these levels, there is a software that is used to calculate matrices and then even higher order matrices. But at this level, unfortunately, there is no shortcut. If it is A to the power 8, it will just be A times A 8 times. Okay.
Sir,
whoa. I'm trying to simplify your life here. And that is the only way that I'm simplifying your life. And in addition to making it more simpler, is that if you are given that kind of a matrix, believe me, it will be a simpler matrix. It will be a 2 by 2 matrix. It won't be a 3 by 3 or 4 by 4. That one I can guarantee you. Because they know that at this point in time, they are not allowing you to use that software.
Say.
Are you happy now?
Level? I'm not happy.
You are not happy because you don't want to do it manually.
Even the software Octave.
You have
no, I'm not happy, sir, because like last time you were showing us something here that if you are having a matrix to the power it's a higher order matrix, we are using this formula. It was there. You showed us to us. I written it somewhere, so now I don't have that book in to me. So if Lerato, you are having that to you, can you just please show to say what I'm talking about?
The thing Say is saying, the one that says hold up. If there are 5 matrices, A to the power 5. We're just doing what Say said in a shortcut. That's how the sigma works. For example, you will say 3 times 3 for 3 and the first matrix, for the first 2 matrices. And then you say times 3 for the third one, times 3 for the fourth one, times 3 for the fifth one, plus 1 times 2 for the first one, 1 times 2 again, 5 times. The same thing, but this.
Whoa.
It's deep.
No. Level.
It's fast.
Level.
Yes, sir.
Okay. And everybody else. Let's, for example, look at number 19. You see this matrix A in number 19?
Yes, sir.
Let's say
Yes.
it is this matrix to the power 5. Okay.
Mm.
You will have 5 of these matrices with multiplication signs in between. Okay.
Yes, sir. Yes.
Then you will take the product of the first 2 matrices. You will get the product of the first 2 matrices. Are we together?
Yes, sir.
After that, after getting an answer, then you will take that answer and go to the third matrix. Okay.
Yes.
You multiply with that. After getting an answer, you will go to the fourth matrix. After getting an answer, you will multiply with the last matrix.
Okay.
Yes.
What is 100 now?
Up to 100, my sister.
No, sir.
My lady, unfortunately, that is the only way that you'll have to do it at this point in time.
Unfortunately, sir, I don't have my book, the usual book I'm using to me.
Or you say there is something that I did share with you.
Yes, there was. There was
Okay.
something.
Okay. Now that you want it, you won't find it. During your spare time, look for it. Next time when we meet, come with it.
Yes, sir.
Then we'll take our discussion from there.
Sir,
Okay, thank you, Lebo. Yes, who's talking?
Lerato.
Yes, Lerato, I'm listening.
The final matrix for 19 is 41, 15, 27, 10.
41,
15,
15,
27, 10.
27, 10. Do they agree?
Yes.
Please talk to them.
They have no choice.
For which one? Number 8.
For
19.
98. I disagree. I disagree.
I also disagree.
How you have no choice? He said we have no choice. I disagree.
What's the problem?
The problem is 10, and I can't remember other one.
27.
27.
Also disagree.
People, what is the final matrix that we are agreeing on for A cubed?
7
Lerato,
times 3 is 21. 3 times 2 is 6. 21 plus 6 is 27. They got 30 there, I don't know how. And then the other side, they got 11. I don't know.
is there anyone who can help us? Because, okay, that one, Vincent, we agree that we are not considering the matrix that you have given us, né? Vincent? We agree.
Okay. Yeah.
And then Mike, Iyo, Nomtandazo, Vuyo, and Lerato. Lerato, now you are giving me a different. It's 41. Mike said 41, 15, 30, and 11. Now you have changed your mind. In the second row, you have got 27, you have got 10. How?
Because 7 times 3 is 21. 3 times 2 is 6. 7 plus 6, 27. 21 plus 6, 27. 7 times 1 is 7. 3 times 1 is 3. 7 plus 3 is 10.
What are we saying?
Sorry, it's Lerato, ne?
It's Lebha.
Yes, it's Lerato.
Lerato.
Yes.
I don't know where you got the 7 now.
Oh, let's agree first.
Can you go?
The A squared, it's 11, 4, 7, and 3.
No, it's 11, 4, 8, 3.
Yes. What do you get 8? Because 2 times 3, it's 6. 1 times 2.
Yes.
Yeah, you
So
see,
it's
2 times 3, that's 6. Plus 1 times 2, that's 2. So if you say 6 plus 2, that's what? That's 8.
8 times 3 is 24, then plus 6 is. Oh, I see where you get it now. It's fine.
Yeah, you still don't get it.
I get it. 41, 15, 30, 11. It's fine.
Before we agree on a cubed, there has to be an agreement on a squared.
Yes, we
Is there
agree,
an
sir.
agreement? Sorry?
Yes. It's 11. Yes.
Now, where is the disagreement?
Agreement is 11,483 on A squared.
Okay, Lerado, you are saying to me there is an agreement on a squared.
Yes. And also
Now, what is an agreement on a cubed?
it's 41, 15, 30, and 11.
You now changed from the 27 and the 30 and the 10.
Yes. To 30 and 11.
Yeah.
Stop.
Yeah. All right. Yeah, thank you, Larato. Is there okay? Is there an agreement on 41, 15, 30, and 11?
Yes, there is an agreement.
Yes.
Okay. If there is an agreement, can we then agree to stop here to say when we meet next time, we'll finalize? Oh, yeah. We'll look at. Oh, yeah. We'll look at 19A. We'll look at 19B and C. Then we'll look at 20, 21, 22, 37, and 38. Then we'll move on to the next section.
No problem. So before you cut this off, for letter B, if I may allowed to discuss it now, so I want to do it next time.
Speak.
What are you saying, Level?
I don't know if I'm allowed for us to discuss letter B quickly because I want to tackle it on my spare time. So,
okay.
Yes, sir. Are we going to multiply 2 inverses and functional matrix?
As sort of a hint, ne?
Yes, sir.
Let me walk with you down this bridge that I'm staying under. Are you still with me?
Yes, sir.
Are you here? Do you see what I've highlighted, Level?
What is it? Oh, yeah.
You see this?
Yes, sir. Oh, okay, sir. Thank you.
Okay.
Thank you. Yeah.
Have I helped?
Too much.
Thank you. And I hope everybody then will not have any problem. And if we are all happy, then do we agree that we'll stop here?